Alright, pre-algebra people again. We're looking at section 9.2. Some of you got this really easy last night. Some of you got it really super simple because you used a calculator. And the problem is on these, they're not looking for the calculated answers. They don't want the answers in decimal. They're wanting the answers still in a radical form, in the square root form. It is something that you're going to apply later on. When you do it in a decimal form, it can throw off some answers, but you're looking for the staying in radical form. So as we look here, there's a couple shortcuts, a couple things that make it a little bit easier, but one thing is first and foremost is you're going to need to know your squares. If you don't know what the square of 9 is, if you don't know what the square of 7 is, or all the way up to at least 15, then it's going to cause some problems. You should know that 12 times 12 is 144. Those are things that are going to be very easy and things that should just pop into your head. If you don't know those already, you've got to go study those, because that's the quickest and easiest way to work these out. The long way is a little laborious, how we've done the factors in the past. That would be the long way to work each one of these out. So as we look at the square root of 12, we know that there's not just a perfect number that gives us a perfect square that equals 12. So we've got to figure out what are factors. What are things that give us 12? 1 times 12 is 12, 2 times 6 is 12, and 4 times 3 is 12. Which of those factors has a perfect square in it? Not 2 times 6, it's 4 times 3. So if we say the square root of 4 times 3, we now have something we can factor out. What is the square root of 4? The square root of 4 is 2. So 2 would come out of the radical, and there's not a square root of 3, so it would stay in the radical. So our final answer would, if written better, 2 times the square root of 3. And that is what we would come up with as our answer. Not factoring out and multiplying with our calculator and giving us a decimal there. That's not what we're looking for. We don't want to see the decimal as your answer when it comes to these types of questions. If we did do that, the square root of 12 is 3.464. That's not what we're looking for. We don't want 3.464. We want 2 times the square root of 3. If we look at this one over here, it's a fraction. Everybody hates fractions. It always throws people off. But you still just got to remember a fraction is just division. A fraction, it still works out and follows the same principles as everything else. The square root of 81 is 9, and the square root of 4 is 2. So we take those out of the radical sign, out of the square root. And so our answer becomes 9 over 2. Square root of 81 over 4 is 9 over 2. Some bigger numbers that follow the same principle. Square root of 250 and the square root of 288. If we type them into our calculators, we'll get some decimal type of answers because they're not perfect squares. So if we did 250 in our calculator, we would get a number along the lines of 15.811. Not exactly what we're looking for. That's not we want to keep it in a radical form. So we've got to figure out what are things that are multiples of 250 that have a perfect square in them. The good thing about a number like 250, it's got a 0 in the end of it, so we know that we can just take that 0 off because that's multiplying by 10. So we have 25 times 10 as square roots. Well, do we know what the square root of 25 is? Well, yes, it is 5. So that goes on the outside. And 10 would stay on the inside. So our answer would be 5 times the square root of 10 is the square root of 250. Same thing on 288. Well, this is one of those logic things. The shortcut is using your brain and thinking, okay, 88, almost a double of 88, 44, 144, 144, or 144 times 2 is 288. We're basically going through and finding the multiples. There are quick math tricks in your brain that you can work out, but if not, you can work out and do the factors of it. But the factors are 144 times 2. Square root of 144, like I said, you should know that that is 12 and 2. So the answer is 12 times the square root of 2. Okay, so here's one a little bit more difficult. It would seem like the numbers would be easy. It's 300x, square root of 300x. And there's two different ways I've got on the screen to show you how to do these. If we just did it the basic way of taking the 2 out and getting a factor, we have the 2. 2 times, it gives us 2 times 150. Well, that's still not a number we can square, so we've got to take it back down. So that takes us out, so it's going to be 2 times 2. And then 150 divided by 2 is 75. Okay, so we still can take that further out, and we get 5. 5, because 2 doesn't go into 75, but 5 will go into 75, giving us 5 and 15. These are all prime numbers and prime factoring out. 15, we can take 5 out of it again and give us 3. So we have 2 times 2 times 5 times 3. Now, if we take 2 times 2, 4, times 5 is 20, times 5 is 100. That gives us a number that is a perfect square, leaving us 3 left over. So we'd have 3 times 100. Okay, another way that we can factor this out is if we look at this one right here, 300x. If we take the 3 out of it, it gives us 3 times 100. 100 is the perfect square. So there's the long way, which does all this, or we can just do mind tricks and think of the quick way. 3 times 100. Still follow the same process. The 10 times 10 is 100, goes on the outside. 3 stays inside with the x. The x stays on the inside. So our answer for the square root of 300x is 10 times 3x. Alright, for our last section of section 9.2, we have variables and their exponents. It still works the same exact way. What times itself will give you the answer that you need. That is what a square root is. So if we have n to the 5th, that is not an even number, so we're going to have something left over inside of it. Well, n to the 5th, n squared times n squared would give us n to the 4th. It's almost like you have a bunch of little n's. N squared times n squared times n is n to the 5th. So these two times each other will give us n to the 4th. So n squared times n is our final answer. N squared times n gives us our final answer. So if we look at a to the 8th, well, n squared times n squared times n squared times n squared. That's 4 of them. So our n to the 4th, a to the 4th, would be our answer. And that is like a perfect square. Because you have to remember that when you are multiplying exponents, technically you're adding them. So a to the 4th is the square root of a to the 8th. If we look at our last one, if we just learned that a to the 8th is a to 4th, well, n to the 4th is going to get us all the way up to 8, and there'll be 1 left over. So we'll have n to the 4th times n as our number there. So the difference is when you're doing exponents, you got to remember that when you are multiplying exponents, technically you are adding them. You're not just multiplying them all the way out. So n to the 5th would be n squared with the n left over. A to the 4th is a to the 8th is a to the 4th, and n to the 9th, since we just learned that a to the 4th goes all the way up to 8. Well, there's only 1 left over, so it's n to the 4th times n, and that will help you with those.